Hello students, welcome to this lecture. So in this lecture we will discuss NCERT sections 10.5.2 and 10.5.4 and examples 9 to 30. This is disclaimer. So first we will discuss eccentricity. Okay, so how can we find eccentricity of ellipse? That we will discuss first, and then we will discuss lattice rectum of ellipse. Okay, and examples 9 to 30. So students, first of all, make sure you have with your notebooks and pens ready. So let's get started. So what is eccentricity? So eccentricity basically measure how much it deviates from being a perfect circle. Okay, so this means eccentricity. So eccentricity is denoted by E. Okay, so eccentricity is denoted by E, and we know that eccentricity, this is equal to C upon A. Okay, so this is by definition of eccentricity. So this is the formula to find eccentricity of an ellipse. Okay, so E equal to C upon A, where C is basically the distance between center and the focus. Okay, and A is basically length of semi major axis. And we also know this formula C, this is equal to square root of A square minus B square. Okay, so in our previous lecture there we established this relation between A, B and C. Okay, so C, this is equal to square root of A square minus B square. Now put the value of C. So C, this is equal to square root of A square minus B square, and now put the value of C in eccentricity E equal to C upon A. Okay, so here put the value of C. Then we have eccentricity E, this is equal to square root of A square minus B square upon A. Okay, and this is equal to square root of 1 minus B square upon A square. So this is another formula to find eccentricity of an ellipse. Okay, so E, this is equal to square root of 1 minus B square upon A square. So therefore eccentricity E, this is equal to square root of 1 minus B square upon A square. So you should keep in your mind this formula. Okay, this will help us to find eccentricity of an ellipse. So for an ellipse, here you can see the value of C. Okay, the distance between center and the focus is greater than 0 and less than A. Okay, that means C always lies between 0 to A. So eccentricity, you can see here, eccentricity will must lie between 0 to 1. So for an ellipse, eccentricity is greater than 0 and less than 1. Okay, so you should remember this condition. So we have seen when eccentricity is 1, that case we obtain parabola. Okay, when eccentricity is greater than 1, that case we will get hyperbola. So when 0 less than E less than 1, that case we will obtain ellipse. So for an ellipse, eccentricity always lies between 0 to 1. Clear? So you should remember here this formula E equal to square root of 1 minus B square upon A square. Okay, and E always lies between 0 to 1. I think it is clear to all of you. Now we will discuss lattice rectum. So how to derive length of lattice rectum for an ellipse. Okay, that we will discuss now. Okay, so see this figure. In this figure, you can see this line segment, okay, and this line segment. These are basically lattice rectum of an ellipse. Okay, so for this ellipse, the lattice rectum are basically CD and AB. Okay, and we have to find here the length of lattice rectum AB and CD. Okay, so now we are going to derive length of lattice rectum. So here AB and CD are lattice rectum for this ellipse. Okay, and we want to find the length of AB and CD. Okay, AB or CD, that we have to find here, that actually the length of lattice rectum. Okay, and for this we have to find the end point of coordinate of AB. Okay, so for find length of AB, we need to find the end point of coordinate of AB. Okay, that means we have to find here the coordinate of A and also the coordinate of B. Then we can easily find out the distance between A and B point, and that will be the length of lattice rectum. Okay, so in step 1, first consider the ellipse x square upon a square plus y square upon b square equal to 1. Okay, so consider this ellipse. Okay, standard form of an ellipse, x square upon a square plus y square upon b square equal to 1. Okay, and here the lattice rectum passes through a focus if. Okay, so here this focus is basically c comma 0. So the coordinates of the focus point is to are c comma 0. Okay, and here this lattice rectum passes through this point. Okay, through this point c comma 0. So what can we say? So the end point have x coordinate here c. Okay, so here you can say the x coordinate for this endpoint A and B must be C. Okay, since equation of AB is basically x equal to C, so equation of this line is basically x equal to C. So endpoints have x coordinate as a C. Okay, so now substitute here x equal to C into the standard form and equation of an ellipse, x square upon a square plus y square upon b square equal to 1. So if we substitute here x equal to c in this equation, then we get c square upon a square plus y square upon b square equal to 1. Okay, so after substituting x equal to c into the equation x square upon a square plus y square upon b square equal to 1, we get c square upon a square plus y square upon b square equal to 1. Okay, so what we have done here? So we did here, we first consider the ellipse x square upon a square plus y square upon b square to 1. Okay, and here the lattice rectum AB passes through a focus A c comma 0, and the end point have x coordinates c, since the equation of this line is x equal to c, and then we substitute x equal to c into the equation x square upon a square plus y square upon b square equal to 1, and then we get this equation. Okay, so note this equation. So in step 3, now solve for y square. So if we solve for y square, then we will obtain y square upon b square. This is equal to 1 minus c square upon a square. Okay, so if we now simplify this, then you will get this is equal to a square minus c square upon a square. Okay, so y square upon b square, this is equal to a square minus c square upon a square. Now use this formula, b square equal to a square minus c square. Okay, so we already know this formula, b square equal to a square minus c square. Okay, so we established this formula in our previous lecture. Okay, so note this formula, b square equal to a square minus c square, and we apply here this formula into this above equation, y square upon b square equal to a square minus c square upon a square. Okay, so in place of a square minus c square, we can write here b square. Okay, so which will give us y square upon b square equal to b square upon a square. Okay, so we get here this equation y square upon b square equal to b square upon a square. Okay, and from here you can solve for y square now. So y square, this is equal to b to the power 4 upon a square. Okay, so y square, this is equal to b to the power 4 upon a square. Now taking square root both side, then it will give us y equal to plus minus b square upon a. Okay, so from this equation we will obtain the values of y are plus minus b square upon a. Okay, now the end points of a and b are c comma b square upon a and c comma minus b square upon a. Why? Because we've already seen the end points of a and b. Okay, the end points of a and b x coordinate is c. Okay, since we know the equation of ab is x equal to c, so x coordinate should be c, and here we have found here y equal to plus minus b square upon a. Okay, so the end point a will be c comma b square upon a. Okay, and the end point b will be c comma minus b square upon a. Okay, so we obtain here the end points of a and b. So since we know the length of lattice rectum is the distance between end point of a and b. Okay, so as we know, AB is basically length of lattice rectum, and we found here the end points of a and b. Okay, and they are c comma b square upon a and c comma a minus b square upon a. Okay, so now if we find distance between the end point a and b, and that will give us basically length of lattice rectum. Okay, so if we find distance between a and b, then it will give us length of lattice rectum. So now find distance between point a and b. So which is equal to basically b square upon a. Okay, b square upon a minus of minus b square upon a. Okay, and this is equal to 2b square upon a. So the distance between the point a and b is basically equal to 2b square upon a. Okay, and you can easily find here because you can see the x coordinate for both end point basically c. Okay, and here basically we have to find the modulus of difference of b square upon a and minus of minus b square upon a. Okay, so this is equal to basically 2b square upon a. So this is actually our distance between end point of a and b. So therefore length of lattice rectum for an ellipse is 2b square upon a. Okay, so when we have given standard equation of an ellipse x square upon a square plus y square upon b square equal to 1, okay, and a is greater than b, that case length of lattice rectum for this ellipse is 2b square upon a. Okay, and you may ask now, what is the length of lattice rectum for an ellipse which standard form of an equation is given to us x square upon a square plus y square upon b square equal to 1 when a is less than b. Okay, that case length of lattice rectum is 2a square upon b. Okay, so when a is greater than b, that case length of lattice rectum 2b square upon a. When a less than b, that case the length of lattice rectum is 2a square upon b. Okay, now see here standard forms of ellipse. Okay, so see here some properties of horizontal ellipse and vertical ellipse. So already we discussed about horizontal ellipse, okay, and vertical ellipse. So standard forms of horizontal ellipse is basically x square upon a square plus y square upon b square equal to 1 when a is greater than b. Okay, so you should keep in your mind this point. A is greater than b, that case this standard equation represent horizontal ellipse. Okay, when a less than b, that case this standard equation represent vertical ellipse. Okay, so when a is greater than b, that case x square upon a square plus y square upon b square equal to 1. This is horizontal ellipse. When a less than b, that case x square upon a square plus y square upon b square equal to 1. This is a vertical ellipse. Okay, so you may write this equation in this form: x square upon b square plus y square upon a square equal to 1 when you have not you have given always a is greater than b. Okay, so we have taken here a greater than b, that case this equation. When a less than b, that case this is the uh, standard form of vertical ellipse. Okay, now we will see some properties. Okay, so what is the major axis? Okay, major axis of horizontal ellipse. So major axis for horizontal ellipse is along x axis. Okay, so major axis for horizontal ellipse is along x axis, and major axis for vertical ellipse is along y axis. Okay, and center for both 0 comma 0. Okay, so for center for both ellipse at origin 0 comma 0. And now find vertices. So what are vertices for horizontal ellipse? So for horizontal ellipse, vertices are plus minus a comma 0. Okay, so for horizontal ellipse, vertices are plus minus a comma 0, and for vertical ellipse, the vertices are 0 comma plus minus b. Okay, and then length of major axis. So for horizontal ellipse, length of major axis is 2 times a, and for vertical ellipse, length of major axis is 2 times b. Okay, and now relation between c, b, and a. So for horizontal ellipse, the relation between c, a, and b is basically c square equal to a square minus b square. Okay, so this relation for horizontal ellipse, and c square equal to b square minus a square, this relation for vertical ellipse. Okay, and then eccentricity e. So eccentricity for horizontal ellipse is basically c upon a, and eccentricity for vertical ellipse is c upon b. Okay, and then lattice rectum. So length of lattice rectum for horizontal ellipse is 2b square upon a. Okay, and length of lattice rectum for vertical ellipse is 2a square upon b. Okay, so these are some properties for horizontal ellipse and vertical ellipse. So you should keep in your mind these properties for horizontal ellipse and vertical ellipse. These will help you to solve many problems related ellipse. Okay, now we will discuss some example. Okay, so let's discuss example 9. So in this example we have to find the coordinates of the foci, the vertices, the length of major axis, the length of minor axis, okay, and the eccentricity and the lattice rectum of the ellipse. Okay, that means length of lattice rectum of the ellipse, and we have given the equation of the ellipse is x square upon 25 plus y square upon 9 equal to 1. Okay, so we have given this equation, and then we have to find the coordinates of foci, the vertices, the length of major axis, the minor axis, the eccentricity, and the length of lattice rectum. Okay, students. So first of all, try it yourself. You have 1 minute to try to solve this example, and after that we will solve this example. Okay, students, now we will solve this example. So what we have given in this example? We have given in this example the equation of ellipse is x square upon 25 plus y square upon 9 equal to 1. Okay, and then we have to find here the coordinates of the foci, the vertices, the length of major axis, the minor axis, the eccentricity, and the length of lattice rectum. Okay, so let's solve this example step by step. So given here, the equation of the ellipse is x square upon 25 plus y square upon 9 equal to 1. Okay, this is our given ellipse. So now compare this equation. Okay, now compare this equation with standard equation of ellipse, that is x square upon a square plus y square upon b square equal to 1. Okay, so if we compare this equation with standard equation of ellipse x square upon a square plus y square upon b square equal to 1, then you will obtain the values of a square and b square. So we get here a square is equal to 25 and b square is equal to 9. Okay, and after taking square root 1 both sides, we will obtain the value of a is 5 and the value of b is 3. Okay, so a is 5 and b is 3. And since here a is greater than b, okay, so here you can see a is greater than b, so it implies major axis is along x axis. Okay, we know when a is greater than b, then the major axis is along x axis. When a is less than b, that case major axis is along y axis. Okay, since here a is greater than b, so major axis is along x axis. And we know this relation c equal to square root of a square minus b square. Okay, so now we use this relation. Okay, and we find the value of c. So just put here the value of a square is 25 and the value of b square is 9 in this relation, and then you will get c equal to square root of 25 minus 9, and this is equal to basically square root of 16, and this is equal to 4. Okay, so the value of c is 4. So we get here a is 5, b is 3, and c is 4. Okay, so therefore the coordinates of the foci are basically plus minus c comma 0. Okay, so the coordinates of the foci are plus minus c comma 0, and we obtain here the value of c is 4. So just put here the value of c is 4, and then we obtain the coordinates of the foci are minus 4 comma 0 and 4 comma 0. Okay, so these 2 points are the coordinates of the foci. And now vertices of the ellipse is one x-axis. Okay, since here a is greater than b, so major axis is along x-axis. So vertices should be one x-axis. Okay, so vertices of the ellipse is one x-axis. So the coordinate of the vertices is basically plus minus a comma 0. Okay, and which is equal to minus 5 comma 0 and 5 comma 0, since we have a is equal to 5. Okay, so a is equal to 5, so the coordinate of vertices are basically plus minus a comma 0, that are basically minus 5 comma 0 and 5 comma 0. And length of major axis is basically 2 times a, so here a is 5, so length of major axis is 2 times 5 is 10 units. Okay, and length of minor axis, that is 2b, so here b is equal to 3, so length of minor axis is 2b, this is equal to 2 into 3 is equal to 6 units. Okay, and we know eccentricity for an ellipse is c upon a. Okay, when a is greater than b, so eccentricity is c upon a, and we have here c is equal to 4 and the value of a is 5. Just put here the value of c is 4 and a is equal to 5 in this formula, then you will get eccentricity is 4 upon 5. Okay, so eccentricity is 4 upon 5. And length of lattice rectum, in this case a is greater than b, so length of lattice rectum is 2b square upon a. Okay, and b is equal to here 3 and a is equal to 5. Okay, and put the values of a equal to 5 and b equal to 3, in this formula 2b square upon a, then you will get length of lattice rectum is 18 upon 5. Okay, so length of lattice rectum is 18 upon 5. So our answer we obtain here, the coordinates of the foci are minus 4 comma 0 and 4 comma 0. The coordinate of the vertices are minus 5 comma 0 and 5 comma 0, and length of major axis is 10 units, length of minor axis is 6 units, eccentricity is 4 upon 5, and length of lattice rectum is 18 upon 5. Okay, so I hope this example is clear to all of you. So now let us move to the next example. So in this example, we have to find the coordinate of the foci, the vertices, the length of major and minor axis, and the eccentricity of the ellipse 9x square plus 4y square equal to 36. Okay, so we have to note here this equation 9x square plus 4y square equal to 36. Okay, and we have to write this equation into the standard form an ellipse. Okay, that is x square upon a square plus y square upon b square equal to 1. Okay, and then we have to find here the coordinates of the foci, the vertices, the length of major and minor axis, and eccentricity. Okay, students. So first of all, try it yourself. So you have 1 minute to try to solve this example. Then we will solve this example. Okay, students. Now we will solve this example. So the given equation of the ellipse is 9x square plus 4y square is equal to 36. And now convert this equation into the standard form of an ellipse. Okay, then for that we divide both sides by 36. And we get here x square upon 4 plus y square upon 9 equal to 1. Okay, so 1 dividing 36 both sides, we obtain the equation x square upon 4 plus y square upon 9 equal to 1. And this equation is of the form x square upon a square plus y square upon b square equal to 1. So now compare the given equation x square upon 4 plus y square upon 9 equal to 1 with standard equation x square upon a square plus y square upon b square equal to 1. Okay, so if we compare this equation with this standard form, then you will obtain the values of a square and b square. So we get a square is equal to 4 and b square is equal to 9. Okay, so after comparing the given equation with the standard equation x square upon a square plus y square upon b square equal to 1, we obtain a square is equal to 4 and b square is equal to 9. And from here you will get a is equal to 2 and b is equal to 3. Okay, and since here a is less than b, okay, here you can see 2 is less than 3. Okay, so a is less than b, so major axis is along y axis. Okay, so here major axis is along y axis, and we know this relation c equal to square root of a square minus b square. Okay, it should be actually c equal to square root of b square minus a square. Okay, so then you will get c equal to square root of 9 minus 4, and this is equal to square root of 5. Okay, so c, this is equal to square root of 5. And here A is equal to 2, B is equal to 3, and C is equal to root 5. Hence, the foci are basically foci for x square upon a square plus y square upon b square equal to 1 when a is less than b. That case, the coordinate of the foci are 0 comma plus minus c. Okay, and here c is equal to root 5, so the coordinate of foci are 0 comma plus minus root 5. Okay, so the foci are 0 comma root 5 and 0 comma minus root 5. And vertices are basically 0 comma plus minus b. Okay, so here the value of b is 3, so just put the value of b is 3 in this coordinate, and then we will obtain the vertices are 0 comma 3 and 0 comma minus 3. Okay, so vertices are 0 comma 3 and 0 comma minus 3. And then length of major axis, that is here, since here a is less than b. Okay, so b is here greater than a, so length of major axis is basically 2 times b, and the value of b is here 3, so length of major axis is 2 times b. This is equal to 2 times 3 equal to 6 units. Okay, so length of major axis is 6 units. And length of minor axis, here length of minor axis is basically 2 times a. Okay, so 2 times a, that means 2 times 2, this is equal to 4 units, since we have here a is equal to 2. Okay, so length of minor axis is 4 units. And then eccentricity. Okay, so we know x square upon a square plus y square upon b square equal to 1 when a is less than b. That case, eccentricity for this ellipse is c upon b. Okay, so e is equal to c upon b, and here c is equal to root 5 and b is equal to 3, so eccentricity e is equal to root 5 upon 3. So our answer will be the foci are 0 comma plus minus root 5, the vertices are 0 comma plus minus 3, the length of major axis is 6 units, length of minor axis is 4 units, and eccentricity is root 5 upon 3. Okay, so I hope it is clear to all of you. So now let us move to the next example. So in this example, we have to find the equation for the ellipse that satisfies the given conditions. So we have given here the vertices for this ellipse, okay, and the foci of this for this ellipse. Okay, so basically we have given the coordinate of vertices, that is plus minus 13 comma 0, and the coordinate of foci are plus minus 5 comma 0. Okay, and then we have to find the equation for the ellipse that satisfy the given conditions. Okay, so students, first of all, try it yourself. You have 1 minute to try to solve this example, and after that we will solve this example. Okay, students, now we will solve this example. So in this example, we have given the coordinate of vertices are plus minus 13 comma 0, and the coordinate of foci are plus minus 5 comma 0. So let's solve this example step by step. So given that the vertices and foci are on the x-axis, okay, so here you can see the vertices and foci are on the x-axis. So therefore, the major axis is along the x-axis and center is at origin 0 comma 0. Okay, so we can conclude from the given coordinate of vertices and foci, the major axis is along the x-axis and the center is at the origin 0, 0. So now the equation of the ellipse is of the form x square upon a square plus y square upon b square equal to 1. Okay, and from the vertices, we know for this ellipse, vertices for this ellipse is plus minus a comma 0. Okay, so from the vertices plus minus a comma 0, and this is given to us plus minus 13 comma 0. Okay, and by comparing, we get a is equal to 13, and from the foci plus minus c comma 0. Okay, the coordinates of the foci for this equation x square upon a square plus y square upon b square equal to 1 are plus minus c comma 0. Okay, and we have given the coordinate of the foci are plus minus 5 comma 0. So plus minus c comma 0, this is equal to plus minus 5 comma 0, and after comparing you will get c is equal to 5. So we obtain here a is equal to 13 and c is equal to 5. And we know this relation a square is equal to b square plus c square. Okay, so we know this relationship, and we can now find by substituting a is equal to 13 and c is equal to 5 in this relationship, and we will obtain the value of b square. Okay, so after substituting a is equal to 13 and c is equal to 5 in this relation, we obtain this equation 13 square, this is equal to b square plus 5 square. Okay, and just simplify it. So 13 square is 169 and 5 square is 25. Okay, so you will obtain this equation 169 is equal to b square plus 25, and from here you will get b square, this is equal to 169 minus 25, and this is equal to 144. Okay, so b square, this is equal to 144. So b is equal to 12. So we found that a is 13, b is 12, and c is 5. Okay, so now easily we can find the equation of the ellipse. So a square is 13 square is 169 and b square is 144. So now substitute the values of a square and b square into the standard form x square upon a square plus y square upon b square equal to 1. Okay, so if we substitute the values of a square and b square into this standard form, then you will obtain the equation of the ellipse. So therefore the required equation of the ellipse is x square upon 169 plus y square upon 144 equal to 1. Okay, so this is the required equation of the ellipse which satisfy the given conditions. Okay, so you can recheck the vertices, the coordinate of vertices for this ellipse are plus minus 13 comma 0, and the coordinate of foci are plus minus 5 comma 0. Okay, so you can verify this. So I hope this example is clear to all of you. So now let's move to the next example. So see this example. Read the example very carefully first, okay, and then answer the answer for this example. Give answer for this example. So you have to find here the equation of the ellipse whose length of major axis is 20 and coordinate of foci are 0 comma plus minus 5. Okay, so you have to find equation of the ellipse, and we have given length of major axis 20 and foci are 0 comma plus minus 5. So students, first of all, try it yourself. So you have 40 seconds to try to solve this example, and after that we will see the solution. Okay, students, now we will solve this example. So given length of major axis is 20 unit, okay, and the coordinate of foci are 0 comma plus minus 5. So since the foci are on the y-axis, okay, so the major axis is along y-axis. So major axis is along the y-axis. Okay, and we know the length of major axis for this for vertical ellipse is 2 times b. Okay, so length of major axis is 2 times b, and here this is equal to 20 we have given. So it implies b is equal to 10. Okay, so from here you can calculate b. So here you will get b is equal to 10, and the coordinate of foci for vertical ellipse are 0 comma plus minus c. Okay, and we have given the coordinate of foci are 0 comma plus minus 5. So 0 comma plus minus 6, c is equal to basically 0 comma plus minus 5. Okay, so now compare this and you will get the value of c. So c is equal to 5, and we know that this relation c square is equal to b square minus a square. Okay, this relation b for vertical ellipse. Okay, that means when we have given standard form of an ellipse, x square upon a square plus y square upon b square to 1, and a is less than b, that case the relation of c, a and b is basically c square equal to b square minus a square. Okay, and we've already found the value of b is 10 and the value of c is 5. Okay, so now just substitute here. B square is 100 and c square is 25 in this relation, and then you will get the value of c square. So it implies 5 square is equal to 10 square minus a square, and from here you will get the value of a square is 75. So we obtain here the value of a square is 75, and here a square is 75 and b square is 100. Okay, so now you can easily find the equation of the ellipse by substituting a square is 75 and b square is 100 into the standard form of the ellipse, x square upon a square plus y square upon b square equal to 1. So therefore the equation of the ellipse is x square upon 75 plus y square upon 100 equal to 1. Okay, so this is the required equation of the ellipse whose length of the major axis is 20 and foci are 0 comma plus minus 5. Okay, clear? I hope it is clear. So now let us move to the next example. So in this example we have to find the equation of the ellipse with major axis along the x-axis and passing through the points 4 comma 3 and minus 1 comma 4. Okay, so we have to find here the equation of the ellipse whose major axis is along x-axis and passing through the points 4 comma 3 and minus 1 comma 4. So students, first of all try it yourself. So you have 40 seconds to try to solve this example, and after that we will solve this example. Okay students, now we will solve this example. So first of all, let the standard form of the ellipse. Okay, so let the standard form of the ellipse be x square upon a square plus y square upon b square equal to 1. And since here the points 4 comma 3 and minus 1 comma 4. Okay, so since the points 4 comma 3 and minus 1 comma 4 lie on the ellipse, so what can we say? We can now say 4 comma 3 and minus 1 comma 4 must be satisfied the given equation of the ellipse. So 4 comma 3 and minus 1 comma 4 satisfy the equation of the ellipse x square upon a square plus y square upon b square equal to 1. Okay, since 4 comma 3 is on the ellipse, so x is equal to 4 and y is equal to 3. Okay, so substitute x is equal to 4 and y is equal to 3 into the equation of ellipse x square upon a square plus y square upon b square equal to 1. So this will give us this equation 16 upon a square plus 9 upon b square equal to 1. Okay, so note this equation. And since minus 1 comma 4 is on the ellipse, so x equal to minus 1 and y equal to 4 satisfies the equation x square upon a square plus y square upon b square equal to 1. Okay, that means if we substitute x is equal to minus 1 and y equal to 4 into this standard form of an ellipse x square upon a square plus y square upon b square equal to 1, then we will get another equation. Okay, so then we will get this equation 1 upon a square plus 16 upon b square equal to 1. Okay, after substituting x equal to minus 1 and y equal to 4 into this equation, we obtain this equation 1 upon a square plus 16 upon b square equal to 1. So student, first of all, note this equation. Okay, so basically we obtain here two equations. First equation is 16 upon a square plus 9 upon b square equal to 1, and the second equation is 1 upon a square plus 16 upon b square equal to 1. Now, on multiplying equation 1 upon a square plus 16 upon b square equal to 1 by 16. Okay, so we are now multiplying by 16 into the equation 1 upon a square plus 16 upon b square equal to 1. Okay, and now then subtracting equation 16 upon a square plus 9 upon b square equal to 1. Okay, then you will obtain the values of a square and b square. So we get here b square is 247 upon 15. Okay, and a square is 247 upon 7. Okay, just uh, you can you can easily find you can easily solve b square and a square by using these two equations. Basically, if we multiplying by 16 the second equation, okay, that is 1 upon a square plus 16 upon b square equal to 1, and if we subtract the equation from 16 upon a square plus 9 upon b square equal to 1, then you will obtain b square is 247 upon 15. Okay, and then after substituting b square equal to 247 upon 15 into this equation, you will get the value of a is equal to 247 upon 7. Okay, and now put the value of a square and b square into the equation x square upon a square plus y square upon b square to 1. Okay, so we obtain here the values of a square and b square, and then if we substitute the values of a square and b square in the equation x square upon a square plus y square upon b square equal to 1, then we will get the required equation of the ellipse. So x square upon 247 upon 7 plus y square upon 247 upon 15, this is equal to 1. Okay, and now simplify it. So after simplifying, you will get 7x square plus 15y square is equal to 247. Okay, so after simplifying, you will get this equation 7x square plus 15y square is equal to 247. So therefore, the required equation of the ellipse is 7x square plus 15y square is equal to 247. Okay, so this is the required equation of the ellipse. Who with major axis along the x-axis and passing through the points 4, 3 and minus 1, 4. Okay, clear students? Is this clear to all of you? So that's all for today's lecture. Thank you very much to all of you.